and my name is Virginia Robbins. So first, to introduce myself, I'm from France originally. I'm currently working at Intel ASEC-G, primarily McAfee, for 10 plus years as a senior security software engineer in the endpoint security group. I'm co-founder of TierraCon, it's a new con, and member of DC 503. So I'm interested in malware research and cryptography. So I recently got 2 new kittens, which I love spending time with. Disclaimer, so this is on my own time. So any view expressed here are solely my own and do not represent those of my employer, as a warning. So goal of this talk. So the goal of this talk is to gain understanding of latest fileless malware, or such type of malware can hide the new evasion technique, what are their applications in latest attacks, and what are the possible ways fileless malware of the future could hide to evade detection. So first of all, before we dig into fileless malware, we have to ask ourselves, what's the difference between fileless malware and regular malware? So basically, what is a regular malware? A regular malware is typically stored in the malware binary file in the file system to run malicious code. And unlike their predecessor, this new type of fileless malware will no longer drop small compiled binaries on the compromised system during malicious activities. So typically, the latest technique is primarily to hide in the registry, then delete themselves before running their malicious code. So let's go through some past technique to evade detection to get a background. So in the past, malware developers tried to implement different techniques to circumvent detection of their malicious code. So they did it through different layers of the system. So one of the ways to have it in memory reason malware. They also use the kernel, so they create kernel rootkit. They also hide it in startup code, such as bootkits. They also try to hide in the firmware for firmware rootkit, and also in the VM-based hypervisor rootkit for VM systems. So what is a memory reason malware? So a memory reason malware loads their code into the memory of legitimate process, even OS files. They remain there until activated, then run the malicious code. So it's almost considered fileless because they run in the memory space of the process. But it's not fileless in the sense that it is currently in the latest fileless malware. So examples of such malware are Angler and Run exploit kits. Also, so kernel rootkit malware, they cloak themselves in the kernel, and they add or replace core OS kernel component and device drivers. So they hide by changing the kernel data structure via direct kernel manipulation. They hook the system descriptor table or system call table in Linux. And to make rootkit more difficult, it's advised to only run signed driver in Windows. So the next kind of way to hide is to hide in the firmware and hardware via rootkits malware. So they utilize firmware to generate an infected image in hardware. Typical targeted hardware affected can be routers, network card, hard drive, or BIOS even. And the problem is that there's not enough integrity verification in that layer to be able to detect them easily. So it's a great ground for malware to conceal themselves. So now we're going to move into the latest evasion technique for fileless malware. So how currently typical fileless malware evade detection? So right now, they get in via a file or link in email or vulnerability in a script plugin, for instance. After the user clicks the link of the file, they write their payload into the Windows registry and then disappear. The script is hidden in the registry via diverse techniques. So first of all, they obfuscate themselves from registry inspection by removing the user access privileges. They had a null character in the registry key name, so you cannot view them via regedit. They call legitimate programs such as, currently the hot one is PowerShell. Also in the past, they did WMI to insert malicious code into memory of standard Windows processes. So here you can see the flow of infection. So basically, there's like spam campaign or malicious website that gets clicked, and the dropper creates all the registry entry and add the JavaScript. And then that JavaScript, through different level, end up calling something like PowerShell or WMI, and which execute the different scripts that they get decrypted and then run. So like I was saying, WMI used to be something that was used a couple years ago. So what is WMI is Microsoft implementation of WBM, which is an initiative to develop a standard technology for accessing management information in an enterprise environment. And so it can be used by fileless malware to execute malicious JavaScript. And more recently, PowerShell. So what is PowerShell? It's a task automation and configuration management framework from Microsoft. It's consisting of a command line shell and associated scripting language built on the .NET framework. That's the official definition. So base 64 encrypted malicious payload is written into the registry and then typically executed using the PowerShell script. So here's an example of a PowerShell call in the registry. So there's a decrypted function coded in the registry that calls the PowerShell executable, which run the encrypted payload code. So what are the applications of fileless malware in latest attack? So we have seen click fraud bot. So the more resources the system has, the more traffic it generates, and the more money it makes for the criminals. It's also been seen in ransomware attacks. So they encrypt the victim file and request a ransom to get the decryption key. Also seen in banking Trojan. So they use online banking system to obtain confidential financial data. So now example of fileless malware. So PowerLeaks and Cofter are the more common ones. So they connect via website and click-through ad. They transform the infected system into a click bot. Or for some variant, they download ransomware payloads. Also, XSW kit, which is a variant of GoodKit, FaceBot, and actually a clone of PowerLeaks. It adds additional functionality by bypassing the USC and startup method. It has been used in banking Trojan and malware downloader. So it was first focused on stealing info from French bank, and then they expanded to European banks. And finally, the one we're going to be looking at is Yabest. So this uses like an older technique, WMI to hijack browser shortcut, but it's a newer malware, so I thought it was interesting to talk about it. So we're going to first go through a small deep dive of PowerLeaks. So what are the infection steps for PowerX specifically? So it ought to start from the run registry key with a hidden null character entry, so they cannot be viewed via registry editors. They remove user-level permission on the associated keys to hide both from security products and user accessibility by revoking ACL permissions. They had also an encoding script in the default run entry, and their hidden run key called JavaScript to decode and run the encoded script. So here's anyone that would try to run regedit would not be able to even see anything. So to them, it would look like everything is great. Once the script is decoded, it first checks to see if PowerShell and .NET Framework are installed on the system. And then it executes more code stored in base64 to change the permission of section of memory, so code written to it can be executed. It could get proc address of some exported kernel 32 DLL and user 32.dll to be able to interact with the system. A script variable is used to store the shellcode and an embedded DLL. And once the DLL runs, it calls its malicious payload. So now we're going to go into CoffTur in a more detailed deep dive, which is kind of similar to the first one, but this one is we have done more research on it. So what are the infection steps of CoffTur? So first of all, it started to morph into fileless malware in later versions, so it was not always a fileless malware. So what it first do, it check to see if PowerShell is already present. And then if not, as the other one, it check if the system has online access and downloads PowerShell. It adds a value to one or more registry run key to run a JavaScript via mshstar program. And similar to PowerLeak, it hides their registry entries by starting value name with null or 0-byte character, followed by a series of X characters. So here, if you look at the registry via a different tool than regedit that do not hide null byte character registry entry, you will see the key, which is Xcode, and the call to mshstar JavaScript. And if you see that, then that's most likely a malware. All right. So that JavaScript we call a different JavaScript from another registry entry. So basically, it writes different registry entry to hoop into different layers. So the following is the value of a registry that points to another registry key under this time the HKey current user software entry. mshstar JavaScript and call some ActiveX object and with some different arguments. So this second JavaScript decode and execute a malicious PowerShell script embedded in its scripted code. The PowerShell script runs a shell code that reads another registry entry, which contains the fileless malicious code. It decrypts it and loads it into memory. Once the fileless infection is loaded, then it deletes the file infector from disk. So by the time the infection happens, there's no trace in the file system. So here is the different registry key in the HKey current user software, encoded and obfuscated. So it looks like gibberish, and that's a good indication it's a malware. If you see any key that looks strange like that, not good. So QWOFTR JavaScript code details. The following is the JavaScript code. Is the output of the first level, the obfuscation. And as you can see, it's a base64 encoded shellcode. So it tries really hard to hide itself. So once you decode the base64 shellcode, then you can clearly see then now the PowerShell script to execute the watchdog script. So the PowerShell execution, what it does, it executes the malicious code in the memory of legitimate system file to stay in memory undetected. So typically, the three major ones it uses, it's regsvr32.exe, svcos.exe, drhost.exe. And once the PowerShell code executes, it establishes a connection with a control server. And then you're toast. It collects lots of information from the host machine and perform a series of actions. So first of all, it will collect system info like OS, version, service pack, architecture. It tests if .NET is present, Adobe Flash Player, and latest browser version. It analyzes the system resources. It dynamically receives information from the control server, allowing them to manipulate the attacks without impacting the user and without detection. So the more resources or power the machine has, the more traffic is seen on the network after that. So the evasion technique used by QWOFTR, so one of them is it checks if the machine is running as a VM and whether it has anti-malware products and any monitoring tools. So some of the information collected from hosts include antivirus products like McAfee Virus Scan Enterprise, anti-Virus Shark, anti-VMware. It's also checked for the presence of specific application, .NET framework, Adobe, like I said, latest Internet Explorer browser. So why does it check for that? Because these applications are required so that websites with Flash-based advertisement can be accessed and clicked covertly without detection. So QWOFTR has a click bot. So it's actually aimed to infiltrate the victim system and transform it into a click bot. The click fraud makes money for attackers, so that's the attraction. It takes advantage of the pay-per-click advertising model. Advertisers pay the website publisher when an ad is clicked. Some also QWOFTR variants have downloaded additional payloads that belong to the crypto world family. Once the system has been evaluated, then QWOFTR prepares a browser to crawl through all the pages of the website and click all advertisements. The control server dynamically pushes site hosting ads, and they are clicked randomly. So at this point, the infected system has been transformed into a click bot, continuously performing fraudulent clicks on advertisement. QWOFTR contains hard-coded search string, also used to populate web pages hosting related advertisements, which are randomly clicked by the malware using built-in code. OK, so the third malware we're going to deep dive to is called Yebeast. It's pretty new, but it uses some old techniques. So it hijacks browser shortcut by adding as a browser executable argument https://yebeast.cc. So as a result, yebeast.cc or top-ye sites, as it's called, automatically open whenever the browser gets started. So what's the infection goal? To steal user data, to generate lots of traffic via pay-per-click method to make money. So YABest is considered fileless because it only remains in the WMI. It deletes themselves when run and do not create file on the hard drive. So WMI hiding, typically they register themselves in the root subscription namespace as an instance of the active script event consumer class. And here's you can clearly see here. The instance is called asec and contains a VB script which runs every 10 seconds. And the VB script, here's some of the content of the VB script. It checks for the existence of 14 different browsers to hijack. Yeah, so interestingly, it calls scrcuns.exe instead of wscript.exe to evade detection further. And then here's what it does to the browser shortcut. It adds the YABest browser startup. And then when you start browser, then that's what you will see. So the persistence in fileless malware. So there's a consideration that we might need to trade off persistence for stealth because there's no trace in the file system. But it's less of an issue now than it was in the past because it takes less effort to achieve persistence these days as devices remain online for a longer time, going to sleep with fewer reboots in between. So as a result, malicious code can run for days without interruptions. And most ideal for attack where implementation of a long-term persistence is not really required for success. For instance, in ransomware, attack family, fileless malware need to only remain alive long enough to encrypt and remove original file, then ask for a ransom. And so now we're going to move to question. So here's some related work source reference links. And so one question I have is, what other possible ways could fileless malware hide to evade detection in the future? OK. Yeah.
1 second.
Yeah. How will fileless malware possibly change when Microsoft has a more secure version of PowerShell? I mean, PowerShell 10 was going to put a lot of this stuff to the end. What would you see as the next vector of attack?
Yeah, that's a good question because really PowerShell has some definitely vulnerability to it and it's too open and too powerful. So if Microsoft fixes that, I don't know. I don't know what they're going to use. WMI was one, PowerShell, so we have to constantly be on the guard. And anything that Microsoft releases that is to help remote administrator control remotely another machine, stay on your guard because that could be a place where malware will do malicious activities.
Thank you. Any next? Okay.
Yeah.
I'll just tell you a little quick. On an average day, how much do the fraudsters make off one box, do you figure?
I will have to look it up to answer that. I don't have all the great detail like that. But I know they make a lot of money.
Okay.
So in many of the examples that you gave, the initial infection was still by a file, something that was clicked or downloaded. Are there any examples, and then it was cleaned up afterwards? Are there examples that you have of purely fileless, where even the initial infection isn't by an executable file?
Yeah, I mean, like if you click an email, if you click a link in an email, it will run in the context of an email or in the context of a browser. So it's not really a file in an additional file, an additional executable, in the file system. It's part of a browser, which has access to write to the registry. Yeah, and even if there's like a payload or a file that is dropped, it gets quickly removed before the infection even starts. So any traditional anti-malware product which only focus on looking at the file system will not detect until it's too late. So obviously, many companies are guarding against that now by behavioral detection and things like that. So.
I think you might have answered my question just now, but I was going to ask, why do you think malware families are evolving to use this sort of fileless persistence or using the registry as a persistence mechanism?
Yeah, because typically, like I was saying, typically anti-malware products were highly focusing on detection, like signature detection, hash and of file in the file system. And this kind of infection you cannot detect via those engines that just detect files. So that's why they're moving towards that. But anti-malware companies are catching up, and that's what we're here for.
Thank you, everybody, and special thank you to Virginia. For a lovely talk today.